So this is the PowerPoint on solutions. So if you recall, homogeneous mixture is when um, different substances are mixed together so evenly that you cannot distinguish the different particles within the substance. So like in tea, you cannot tell the difference between the tea, the water, and the sugar. They're all dissolved so evenly. Right? Usually solutions will be liquids, but they can also be solidify into a solid, or they can remain as a gas as well. For clean air would be a gaseous solution. Okay, now in a solution, there are always two types of components. You have the solvent and the solute. Okay, now the solute is what's dissolved within the solvent. Right, so in the case of salt water, salt would be the solute and the solvent would be water. Water is known as a universal solvent. A lot of things can be dissolved in water. Okay. All right, so carbonated drinks, coffee, tea, they're just a few examples of water-based solutions, right? And because substances can dissolve in water, because so many can be dissolved in water, that's why we call water a universal solvent. And we'll get into, when we talk about chemistry and the chemical properties of water, we'll get into why it dissolves things so easily. All right, when we're dissolving, it's just a physical change. Um, and that's because when we dissolve, no new compounds are formed, no chemical reaction takes place. We're just mixing things together. For when for when we're dissolving salt in water, because there's no chemical change, we can easily separate them out again. For instance, you can pour salt water into like a petri dish like here, allow the water to evaporate, and you're left with the salt crystals. Or we could distill salt water. We talked about that before, where you can heat salt water and the water will turn into steam, and then we allow it to cool and condense into distilled water. Okay, for the rate of dissolving. So there's certain things we can do that can increase the rate at which a solute will dissolve in a solvent, right? And anything that we're doing, in order to dissolve, the solute atoms have to come in contact with the atoms of the solvent. So here's your salt atoms that make up the compound salt, and here's your water molecules or the compound water. So these have to come into contact. Anything we do that can increase that contact will increase the rate at which a substance will dissolve. Okay, so there are three ways to increase the contact between the solutes and the solvents: increase temperature, increase surface area, and stirring. Okay, so when we increase temperature, um, remember that particles are always in motion, and when we add thermal energy, we increase that motion. We increase the rate at which the molecules are moving. So since they're moving faster, they have more chances of colliding, right? So increase in the temperature increases the chance of contact. For example, when you dissolve sugar in, it's a lot easier to dissolve sugar in hot water than it is in cold water. Anybody who makes their own sweet tea knows that you don't add sugar to cold tea. It's not going to be the same. The water needs to be hot when you dissolve the sugar in it, and then it turns out pretty well once you let it cool. Another way that we can increase the rate is to make it smaller sizes, or technically speaking, we can increase the surface area that's exposed to the solvent, right? So smaller particles actually have a larger surface area to volume ratio. More of that surface is exposed to the solvent than what's inside, right? So like here's a sugar cube and here are salt crystals, sugar crystals. All right. So in order for it to dissolve this sugar cube, that water's got to interact with every single one of those sugar molecules along the surface before it can even get to the water molecules inside of it. But when you already have it in crystal form, then the water molecules can very easily interact with the different atoms within the sugar crystal. Okay, so that would be increasing surface area that's exposed to the solvent. The third one is stirring, and that's just you're going to physically cause that contact to take place when you stir something, right? So those are the three ways that you can increase the rate of dissolving: increase the temperature, increase the surface area, and stir. Right? So here's the I can statements. Distinguish between a solute and a solvent. A solute is a substance that's dissolved within the solvent. Right? Explain why dissolving something is a physical change, and that's because no new compounds are formed. Right? In a chemical change, new compounds are always formed. In a physical change, you're just mixing things together, and no new compounds are formed. All right, list three ways to increase the rate of dissolving a solute in a solvent. We can do it by increasing the temperature, increasing the surface area that's exposed to the solvent, and by stirring. All right, so that is the end of this PowerPoint.